Okay, hello. So it's my pleasure to be here to present what we've been doing at Ant Financial. So what is Ant Financial? It's a sister company of Alibaba. It's headquartered in China, but we have office in London and also have business in Southeast Asia. So today is about AI. So I'll tell you a little bit what we've been doing AI at Ant Financial. So, okay, so a little bit background about what we're doing. This is a young man in actually in Everest Mountain, and he runs a camping site actually about 5,000 meters above sea level. What we do essentially provide a mobile payment service for him, and that dramatically changed his life because otherwise he will carry lots of cash to the top of the mountain. Another one is a farmer in rural areas. What he needs is the money to buy the seeds for next year's production, or buy a pig. Why do I tell you this? Because there's a connection to what we do. The connection is the financial services provided at Financial. So first one, obviously, is a mobile payment. So this line highlights the milestones of the payment. What to do with the AI? A couple of things. So first one is the smart to pay. So last year in China, so all you need to do in Shanghai is a big city in China. So you can smile to the gateway and you go through the gate. So without buying, if you have a Alipay account already. So that is based on computer vision technologies. So that's the one real application. So another one will be the payment business. The microloan business. So what we have doing is paired with IFC, the World Bank. So they have investment in China to do poverty reduction. So what we do is essentially open up our technologies, in particular AI technology, to share our learning capacity with a credit union actually in China. So that's called rural loan. Basically, it's AI-based shared learning. So now we open up our platform with our partners in China and also actually in Southeast Asia. So to summarize, the technology foundation for Ant Financial is basic in one word. B stands for blockchain, is AI, and S is security, I stands for IoT, Internet of Things, C is the foundation, computing. So in the 5 letters, AI plays a critical role because AI apparently is the driving force for our security service, for our IoT. Basically, with all the sensory information, we need to provide intelligent services. So I'll skip the blockchain, security, IoT, computing. Okay. So the foundation essentially is a technology foundation. But why do we do that? The reason is we provide a collection of financial services. Actually, we are partnered with our partners in our ecosystems to help our users. Because of this ecosystem, we actually have a collection of financial services, including microloan business, insurance, payment, risk management, and so on. So essentially, all these scenarios provide a rich source, actually a collection of sources for new data. So that poses critical challenges for AI researchers. First, we need to process the data really fast. To catch it by, number one, we need to make sure this transaction is done by you, not by somebody else. So that means we need to make a decision in a fraction of a second, so real-time capacity. Number two, the maximum volume. So we have about more than 800 million of users. So that's a huge number. So each day we have more than, say, hundreds of millions of transactions per day. So again, that's a huge number. So given this large volume of data, how do you process them, make sense out of them, find an anomaly, do the risk management? So it's critical. So that's number two. So how to make a system of large volume to handle capable of handling large volume of data. The other one is diversity. Because we can see we have collection of services, can you actually integrate the data from different sources and make sense out of it, okay? A few more challenges. Number one is actually, I didn't list it here, is interpretation. So for financial services, it's critical. You want to make sense out of your predictions. It's not just saying you have a deep learning model with, say, hundreds of layers of neurons, you make a prediction. You want to explain to your users why do you, for example, reject his loan application. Or you want to explain to regulators why you have such a prediction, a decision, okay? So therefore, interpretation is critical for a machine learning system in financial domain. Another one is adversarial learning. Naturally, we have opponents in a financial setting. Doesn't matter you're talking about investment, so market, you investors, or you talk about fraud detection. You're always, because of interest here, you have money on the table, always somebody will try to attack a system. So how do you prevent this from happening? So all these are critical challenges we face at the financial. So last year, we have actually, I met a reporter from MIT Tech Review. After our meeting, went black. He had a article appeared in a Tech Review. It says a Chinese company actually is an AI company. Why is that? Because we actually use AI for almost all the businesses we're conducting in China and worldwide. So here we outlined a few of them: payment, microloan business, wealth management, marketing, customer service, and risk management, and so on. So the core of our financial brain essentially are two things. One is basically machine learning algorithms. Second is knowledge graphs. How do you link things together and make them represent them as a graph and make sense out of it? So this is an architecture of what we're doing. Apparently, we're developing a collection of machine learning methods, including reinforcement learning, graph reasoning, inference, optimization, and so on, also natural language processing. Then we combine all of this into a platform. So that has model training, service, and so on, okay? In the end, we actually turn this into a service, a product, and to help our internal business units. And meanwhile, we are opening up to empower our partners. So the critical thing is that we're building a financial brain for our task. So the three critical features: one is secure, because the data got to be secured. Your prediction, your machine learning system got to be a secure system. Number two, the real time. As I mentioned before, you want to catch bad guys in real-time fashion. Otherwise, it might be too late. Third one, I'm reiterating my point, large scale, because of the sheer volume of data. I'll give you a few examples, concrete examples, to give you an idea of what we're doing. The first one is the graph embedding. Many of you assume, because the AI conference, we're pretty familiar with the deep learning methodology. It's getting really popular in the past few years, and start from actually speech recognition, then computer vision. But it has a small problem, a limitation. The limitation is how do you handle the data that actually have relationships between each other. It's not ID data. It's not a sequence. It's actually a graph, it's a network. So this happens a lot in real-world scenarios. For example, you have relationships between people, like in social network. You have a connection between a person and a device. Also, you have interactions between financial institutes. So naturally, you have a network representation. So how do you combine the power of deep learning with network representation, with a graph representation? So we develop graph embedding technologies. So you might heard of a technology called word-to-vector. That essentially convert a word, actually later the sentence to vector, convert a sentence into a vector representation. But now the task is, can you convert a graph with all the node attributes into a network? Then we can conduct a collection of services. So this is one example I gave actually under financial. We actually use it for a collection of tasks, so from intelligent marketing to microloan business and so on. But this one is fairly simple. We have, as I mentioned before, we have hundreds of users, actually 100 million users worldwide. But if somebody new come to a system, your new account, you want to make sure this is actually real person, not a fake account. It's not a spam, okay? So that is important for the quality of our account management. So how do you do that? At the beginning, you actually have very, very little information about this account. All you know is there's a new account. So can you do something, okay? So then we cannot use a huge neural network or deep learning method to do that because you're going to overfit, given the limited amount of data you have about this particular account. Then we actually combine the relationships. For example, if you know this user have been using some devices that link to somebody else, that gives us a lot of information because not often, if it's a spam, this might be organized problem. They might share cell phones or some devices. That actually gives you additional hint. So we use a network representation to formalize this problem into a new framework. And that will allow us to detect spams. So this is a technical, these two slides shows a technical result, so some technical results. So the right panel is a comparison of the accuracy of actually recall rate versus accuracy. Basically it says how many bad guys you caught, and of course if you catch bad guys, you want to make sure they are indeed bad. You don't want to miss classify good ones into bad ones. So it's called ROC. You can see the new method outperformed the traditional methodology by a large margin. Another one is marketing. If you're a financial institute, you care about how many users. So one core thing is actually intelligent marketing. The other one is actually risk management. So here we use reinforcement learning. If you actually, you might heard of this reinforcement learning technology because it's getting really popular because of AlphaGo, because of the competition between machine and human players. They use AlphaGo, they use the deep learning combined with reinforcement learning for this task, but then we use it for another task in real world, that's marketing. Because you want to make sequential decisions for that task. How do you do that? Without further ado, I just show some results. If you do it well, use this method, you actually can gain a large margin of performance. You can get a huge boost in your performance. So I measured two metrics. One is CTR, basically the click-through rate. The other one, the conversion rate. Essentially, how many of them are actually converted into your users. Okay, third one is about multitask learning. How do you combine information together? Okay, so here I skip this. Essentially, you have a lot of data coming in. You want to combine the data. You have a latent representation, okay? That allows you to have a unified representation of attributes, of user behaviors, products, and so on, okay? So if you look at this picture, what do you see on the right panel? Actually, no, the right figure, right picture. What's the common feature? There are many common features, but one of them is all these young ladies are wearing skinny jeans. So we analyze the data. We figure out an interesting connection. Basically, many of them actually will buy surveys for to replace their damaged cell phone screens. Okay, so what's the use of that? So we actually designed an insurance product, small insurance product called screen damage insurance. Literally designed for those subpopulation who often buy skinny jeans. And we don't recommend this product to everybody, okay, designed for them. So this is just one example for for a small innovation. This actually is a long-term economy. We have many of such examples. This is just one example. It's a little bit surprising. We didn't expect that at the beginning. Okay, give you another example. That one is actually insurance product. So this is a bigger one. It's about vehicle insurance. So we use face recognition for payment as a barcode to basically recognize who you are. But now we see actually can you take a picture of a car and recognize which part is damaged, how severe it is, how much you need to fix it. Okay? So this is a lot harder than traditional, say, face recognition because you don't put paint on your face. Unless you are picking opera, then you have lots of color on your face. But every single vehicle, normal car, has a color. Okay, that causes reflection. And also, when you do face payment, you look at the camera, okay, in the right position. But when you have a car accident, you're doing in a super good mood to look at the region and put into a perfect position to take the picture. So that is we call the image normalization, actually a computer vision registration problem. So this a challenging computer vision problems, and it's super useful. because this task is not really human-friendly. It took years to train to get a human expert to assess the damage of car accidents. If you look at this picture, can you tell which part has problem, if there's any? Anyone? I asked this question many times. Only in one meeting, somebody raised his hand and gave me a correct answer. Actually, 2 times. One got a wrong answer. The other time, a gentleman told me the right answer. The reason is actually he worked in an insurance company for more than 20 years. It takes time to train a human being to do this job. It's pretty boring. But I believe actually worldwide, lots of people doing this job. They look at all the car pictures to say, oh, which part is the problem, okay? How severe it is. So here's the computer vision result. It tells us that part, the fender, has a little bit a deformation. Basically, there's a small change in the shape. It's super hard. And also, I give an estimate. It took like 500 yuan, basically around $40 to fix it. $40 US to fix it, okay? So all of this essentially is a combination of, actually this is just a demonstration of what we're doing. So essentially we use computer vision to come up with a decision process. We look at the damage of the car, we'll tell which part went wrong. It's a hole or it's a scratch or something more serious. And I also give an estimate of the problem, okay? Estimate how much you need to fix it in which location. So this apparently will be super useful, for example, to reduce the traffic jam in big cities, like in Shanghai, for example. Our traffic bureau is super interested in this product. Okay, so this is for insurance. Actually, now we're using OCR, optical character recognition technologies, for our medical insurance problem. Basically, you want to speed up the claim process. Normally take a year, actually take not years, a very long time to do that because they need somebody sitting after the computer to check every single receipt. Now we're doing that using computer vision technologies. So all these products essentially are helping our partners, our business, but this is something else. So this is a new product, intelligent assistant. The design of this product is so the previous product is to improve the efficiency of financial service, reduce the cost of financial service. So this is another example. This example is to improve the user experience of our users, okay? So a few years ago, actually, we started an intelligent customer service project. Why do we do that? Because, as I mentioned before, we have 100 million users. Then we have lots of phone calls to answer for our customer service system. If we do that manually, because also increasing our number of users very rapidly, then we'll have a huge number of labor force just to answer phone calls. And it's pretty boring. So at the beginning, actually, our engineers, including myself, we sit into our customer service system, actually the center, pick up, answer the phone. It's actually psychologically challenging. Also, it's pretty hard for memory because you need to memorize all the products we offer, all the details. So it's another challenging task. So, but meanwhile, you want to give the best experience to your customers in financial service, right, for financial service. So it won't be sustainable if we keep doing a traditional way. So we start an intelligent customer service project. So that showed effect very, very fast. In less than a year, we improve our self-service rate, basically the problem solved by the user themselves, from like 60% all the way to 94%. So what does it mean? That means all the phone calls on Singles Days, like Black Friday in US, I don't know what's the equivalent in UK, but basically many people are calling to buy stuff online. Before that year, actually, you couldn't make a phone call successfully to the customer service center because it's too many people calling. It's like winning lottery in lottery. But now, actually, in that year, since 2015, majority of the problems were handled by a robot. So there are not much problem anymore. And in 2016, 97% of phone calls are handled actually, including both phone calls, also from the typing on either cell phone or laptops, are handled by robots. So you might say, oh, that's cool, but I really hate the experience, right? Because it's answered by robots. That's not good. Because we care about not only the efficiency, but also user experience. So we think, oh, why don't we measure how good we are? So we measure how good we are as a human service providers. We have a set of metrics to handle each customer service staff, how good you were for this particular for our task. We give scores for the performance evaluation. It's tied to your promotion, tied to your bonus in the end of the year. Then we use the same thing to measure the performance of our robot. So a year ago, actually, you can see there's a milestone. A robot is doing a better job than human beings. So that means, on average, we perform better than the same metrics we use to measure our customer service, our real staff. We do a better job on average. So since then, we thought, oh, can we do better to extend this capacity for other tasks? So we extend our capacity from customer service to, say, for example, to insurance product, to user education, to wealth management, and so on. So here, give a few examples. So now you can talk to our app, called Alipay app, and say, I want to buy a ticket to Hangzhou, to Beijing. Without saying where I got started, we'll analyze all the information, give you a list of ticket information. Then you say, OK, I want to, in the morning, a fast speed train, and so on. It'll give you all the answers automatically. You click it, you got the ticket done. You will buy the tickets immediately. Another example is switching topics. This is a harder job for NLP because you're talking about different sections, different topics. You'll switch between them. So you'll say, I buy a train ticket to Beijing. Then once you check the weather, maybe I'll find some restaurants recommendation. So how do you navigate through these different tasks? So that's another interesting topic. So analyzing all this, I give a few examples for reducing cost of financial service. I give you an example about improving user experience. But beneath all of this, essentially, is a powerful platform we're building. That's essentially AI platform that integrates deep learning, reinforcement learning, unsupervised learning, and so on. Of course, we also investigate encryption for data protection, privacy protection, and so on. So in short, I just gave you a few examples and a very simple description about what we're doing. But I think things are more exciting than what I'm talking about today. But in short, we're saying, OK, essentially, we believe technology innovations are critical for for inclusive financial services. And because that's type of our mission, bring to the world more equal opportunities instead of getting more money for yourself. OK, thank you.